Hey, how's it going, folks? This is Mr. Farrell here. So we are currently working on a conservation of momentum problem. This one is for an elastic collision. All right. So currently, we're going to read the problem, break it down through the steps of the ICE method, right? Identify, categorize, equate, and evaluate. All right. And we're going to come up with an answer at the end of this. All right. So hopefully this isn't too far away for you all to see clearly, but I'm going to read the problem twice so that you can write it down for yourself. So the problem says two vehicles crash in an elastic collision. Vehicle 1 has a mass of 2,019 kilograms, and vehicle 2 has a mass of 3,280 kilograms. Initially, vehicle 1 is moving 10 meters per second east, and vehicle 2 is moving 4 meters per second west. After the collision, vehicle 2 is moving 3 meters per second east. What is the velocity of vehicle 1? Okay, so I actually would read it again, but this is recorded, so you can pause and rewind if you want to write it down. All right, so we got our elastic collision problem here. First step is identify, okay? So I'm gonna write my steps of the ICE method over here, ICEE. All right, cool. So with the identify step, we just want to write down all of the measurements in the problem. All right, cool. So we see in this problem 2,019 kilograms. Okay, we see 3,280 kilograms. All right, we see 10 meters per second east. Make sure to get that direction, right? Because it is velocity is the magnitude and the direction. Vehicle 2, let's again, 4 meters per second west. Okay. So again, remember, while you all are doing this step, we're not trying to figure out, is it velocity? Is it mass? That stuff is going to come later. Right now, we're just looking for every single measurement. So is there a number and is there a unit next to that number? So notice I didn't write down vehicle 1 or vehicle 2. Those are numbers right there as well, but they are not measurements. So we're not going to write them down in this step. Okay, so we got 10 meters per second east, 4 meters per second west, and 3 meters per second east. Cool, 3 meters per second east. Great. All right, so I think that covers just about all of the measurements in the problem. Now, the last part of the identify step is to write down the question. That is very important. If you don't write down the question, you don't know what you're being asked. So we read through this problem. We get to the end of it. All right. And it says, what is the velocity of vehicle 1? Okay, so I'm going to write that down real quick. What is velocity vehicle 1? Okay, just shortened it a little bit so I could save some space. Now, it is important to note that this is after the collision. Okay, so I'm going to go ahead and just make a note for myself. This is after collision. All right, because when we start working with all of the variables in the conservation of momentum equation, it's going to get a little difficult to track. So it's important to know that. All right, now 2 other pieces of information that are really important for me to know in this problem is, first, this is an elastic collision. All right, that really helps me because now I know which equation I'm going to use. I'm going to use the equation for an elastic collision. Second of all, I'm going to box where it says after the collision. This is just important to identify so that when I begin to categorize everything in step 2, I know which numbers are the initial values and then which numbers come after the collision. So it just helps me to categorize things properly. All right. So now that we have all of our measurements written down in our question, we are done with the first step of the ICE method, and we're going to go ahead and move on to step 2, categorize. All right. So let me go ahead and write categorize here. All right. Now, here's the cool thing about knowing that this is an elastic collision. Okay. Since this is elastic, I already know the equation I'm going to use, okay? Normally, that's not the case when you're doing a word problem, but they told us that it was. So I know that my equation is going to be M1 V1 plus M2 V2 initial equals M1 V1 plus M2 times V2 final. All right. So I know that is going to be my equation because that is the equation for an elastic collision. So what I'm going to do is I'm going to just write all of these variables in my categorize step because I know eventually I'm going to need all of them. Okay. So let's go ahead and do that. I'll leave the equation up here as I begin to write. So let me just bracket this for myself. So I'm going to say these are my initial values. So this is before the collision. So I have M1, V1, M2, and V2. All right, all before the collision. And then my final values after the collision. All right. Final values are going to be, again, M1, V1, and M2, V2. All right, great. So I'm going to go ahead and erase this equation because I do not need it at the moment. I just listed all of my variables that I'm going to use. Okay, and now the other important thing to note is what is my first object and what is my second object. Now this problem makes it easy for us because they give us a vehicle 1 and a vehicle 2. So all of our 1s are vehicle 1, all of our 2s are vehicle 2. I just want to note that if they don't tell you vehicle numbers or something, you want to make sure in this categorize step to identify what your object 1 is and what your object 2 is. So just out of good practice, we're going to do that now. So I'm going to say object 1. So just OBJ1 is vehicle 1. All right, and then object 2, OBJ2, is vehicle 2. All right, so real simple. So all of our 1s are going to be values for vehicle 1. All of our 2s are values for vehicle 2. All right, so again, just because this was an elastic collision, that is why we were able to list our variables first. Normally, we have to we look at our identify step and we have to categorize each one and figure out what variable it is. However, conservation of momentum problems make it a little easier for us because we already know what we're going to need and what type of problem it is. All right. So here we're just going to go back to our identify step and begin to put these different measurements in categories. Okay, so first measurement we're looking at is 2019 kilograms. All right, so I know kilograms is a unit of mass, but does it belong to vehicle 1 or vehicle 2? Is it before or after the collision? Well, the good thing about masses is that they don't change. So the mass is going to be the same initial and final, so before and after the collision. So now I just need to read through my problem to figure out what mass it belongs to. So I see 2019 kilograms, and that is vehicle 1 has a mass of 2019. Okay, so I'm going to put 2019 kilograms for the mass of vehicle 1. And again, the mass never changes, so I'm going to write it down here as well because the mass of vehicle 1 after the collision is also going to be 2019 kilograms. Okay, let's see. So I can cross that out of my identify list. 3,280 kilograms. Let's find it in the problem. It's right here. And it says, and vehicle 2 has a mass of 3,280 kilograms. So I'm going to write that down for the mass of vehicle 2. 3,280. Let me correct that. 3,280 kilograms. 3,280 kilograms. Again, because the masses never change. All right. So I can cross that off the list. All right. Now we get to 10 meters per second east. Now I know that meters per second is a velocity. All right. So this says 10 meters per second east. Now I'm going to first of all identify which vehicle that belongs to. So 10 meters per second east. I see it right here in the problem, and it says initially vehicle 1 is moving 10 meters per second east. So I'm going to go ahead and write 10 meters per second east in my initial values before the collision for vehicle 1. Okay. Another reason I know this happens before the collision is because it is written up here. Anything that happens after the collision is written after this statement. So since it comes before this statement, after the collision, I know that it happens in the initial step before any crash happens. Okay. So I'm going to put 10 meters per second. All right. Now the tough part is I cannot write east here because when I'm solving a word problem, I can't put east in the word problem. That would just make everything a bit more difficult, right? Because I can't solve a problem with the word east in it. So I actually need to find a way to represent east without writing it. Now, if you recall, you can actually use a positive sign or a negative sign to show what direction something is moving. Okay. So since this is moving east and it's the first one I came across, I'm actually going to decide that east is my positive direction. So I'm going to put a little plus sign next to this 10 just to remind myself that it is moving east. So it's positive. All right. So now I'm going to cross that off the list and we're going to go to the next one. This next one says 4 meters per second west. We need to identify what it belongs to. So I see 4 meters per second west here in the problem, and it says, and vehicle 2 is moving 4 meters per second west. So let me go ahead, write it for vehicle 2. Again, it's going to be in the initial side because it comes before the collision. All right. So 4 meters per second. Now this one is moving west. If I just said that east is positive, that means the opposite direction, west, should be negative. Okay, so I'm going to go ahead and put a negative sign in front of the 4 meters per second. And now I can cross that out. So that negative sign lets us know this is moving west. Okay, now I have a couple more things to identify. So I see 3 meters per second east. I'm going to look for that in the problem. And it comes right here, 3 meters per second east. And the problem says vehicle 2 is moving 3 meters per second east. So since it comes after the collision, I'm going to write it down here in the final side. So vehicle 2 is moving 3 meters per second east. I'm going to find the velocity of vehicle 2, right? Because meters per second is a unit of velocity. I'm going to put 3 meters per second. Now it says it's moving east. I did say east is the positive direction. So I'm going to go ahead and put a plus sign next to this 3 so that I know it's moving east. All right. So I'll cross that off the list. And the last thing to categorize is the question. Now the question says, what is the velocity of vehicle 1 after the collision? All right. So again, the question is something I don't know. So I'm not going to put a number in that spot. I'm going to put a question mark in that spot. So I'm going to look for vehicle 1's velocity. So I'm looking for V1. There it is. And it is after the collision. So final. I'm going to put a question mark. So that is what we are looking for. V1 final. All right. So let me go ahead and cross off the C for categorize because we just finished that step. All right. Now I'm going to need a little bit more space, so I'm actually going to go ahead and erase this problem. All right, cool. So I just erased the problem. So now we should be able to go ahead and write out the equation we're going to use in our equate step. So let me go ahead and write that down. All right, so equate. Now remember, this is an elastic collision problem, so I already know the equation I'm using, which is M1V1 plus M2V2 initial, right? So before the collision equals M1V1 plus M2V2 final, so after the collision. All right. So all I'm going to do is plug these variables into this equation and solve it. Now, normally when you do the equate step, I recommend that you solve it algebraically first, which means don't plug anything in, rearrange the equation using algebra to find the variable you're looking for, which in our case is V1 final over here. So that's what I normally recommend, but if you struggle with algebra, that is a lot to ask. And so if you do struggle with algebra, I recommend just plugging in all of your numbers and just going ahead and solving the problem. So that's how we're going to do that. This one today is we're just going to go ahead, plug in these numbers and go ahead and solve this equation. Okay. So M1, I said it was 2019. All right, so 2019 kilograms is M1. V1 is 10 meters per second. All right, now remember that's a positive 10 meters per second because it's moving east. All right, and notice how I'm writing all of my initial values on the initial side, okay, before the collision. Now, M2 is 3,280 kilograms. All right. V2 is -4 meters per second because this one was moving west. All right. And that's all of my initial values. Okay. Sweet. Now let me go ahead, plug in my final values. Mass 1 is still 2019 kilograms. Velocity 1 is what we don't know. So we're going to leave the variable in that place. All right, and we're going to go ahead and add M2, which is 3,280 kilograms. And that is being multiplied by V2, which is now a positive 3 meters per second. Okay, now I didn't put the plus sign, but that's okay. We know that it is a positive number. I really only have to put the sign with the number that is going west because I need to know that's a negative number. Okay, so I just plugged in all of my variables here. So again, just in an effort to give myself some more space, I'm going to go ahead and erase all of the variables in the categorize step. Now look at that. We got plenty of space to do our problem. I actually might even have another marker here so I can change the color of the variable we're looking for, so that stands out a little bit more. Let's see. Sweet, there we go. So V1 is what we're looking for. Now we're just going to go ahead and solve this equation. So we're going to begin evaluating, okay? So again, normally with the equate step, you want to just rearrange everything algebraically first. But because there are so many variables to keep track of, we're just going to go ahead and solve by plugging in our numbers. So I'm going to cross off this E for equate, and we're going to go ahead and start to evaluate. All right, solid. So 2019 kilograms times 10 meters per second is going to be 2190 kilograms times meters per second. All right. So this is a unit of of momentum, right? Mass times velocity, kilograms times meters per second, all right? And we are dealing with the conservation of momentum equation, so it makes sense. We got units of momentum, all right? Sweet. So now I'm going to add 3,280 times negative 4. Let's do that. 3,280 times negative 4. And that is going to equal a negative. So I can keep my plus sign. I'm just going to have to make this a negative number. So that's plus negative 13120. And my units again, kilograms times meters per second over here. Great. Okay. So I've got a positive number here and I'm adding this negative number over here. Okay. Both of them have the same unit, so that is good to know. That means I have momentum over here, momentum over here. So that's going to be good. All right. Now, again, working across the 2019 kilograms, I can't do anything with that yet because I don't know what V1 is. So I just have to write it again. And now 3,280 times 3. And again, this is a positive 3 here. So I don't have to do anything special with this. I don't have to make it negative. And that is going to equal 9,840. And the units are kilograms times meters per second. All right. Awesome. So let me write this a little clearer. 9,840. All right. Cool. So now, I'm still trying to solve for V1. Okay. So I'm going to combine my like terms. Okay. So these two can be combined. They have the same units. So I'm going to go ahead and combine those. So let's see what we get. 20190. All right, plus a negative 13120. All right, so that is going to equal 7070. All right, let me write it again just a little more clearly. 7070. All right, and my units are still kilograms times meters per second. All right, cool. So we're looking good so far. I don't think you can see this clearly on the camera. Let me rewrite it. Awesome. 7070. Great. So I just combined those. They were like terms. They had the same units. All right. Now I'm going to rewrite everything on this side. V1. Again, can't evaluate this yet because I don't know V1. That is plus 9,840 kilograms times meters per second. Okay. Now, again, I'm still trying to combine like terms. And if you look at this equation, I've got kilograms times meters per second and kilograms times meters per second. So these two are alike. So I can actually go ahead and move this over to this side and combine these terms. Now, here's something that I've begun to think about. If it's helpful, great. If it's not helpful, don't worry about it. But a lot of folks sometimes don't know what to do. Like, what do I move over? What do I do next when I get to this stage? So I like to think of PEMDAS, okay? So when you're evaluating an equation, right, trying to solve it, you want to do parentheses, exponents, multiplication, division, addition, subtraction. So you work PEMDAS from P to S. What I've begun to see is if you are trying to isolate a variable, right? If I'm trying to get V1 by itself, I want to do PEMDAS in reverse. So instead of evaluating numbers so I can solve the equation, I'm going to isolate V1 by doing PEMDAS in reverse. So first I'm going to look and see, is there any addition or subtraction in this problem? All right. So I do see addition in this problem. So I'm doing PEMDAS in reverse, right? So I look for addition and subtraction. I found addition. Now I'm going to get rid of the addition. Okay, so in order to get rid of addition, we have to do subtraction. All right, so I'm going to subtract 9840 kilograms times meters per second. I'm going to subtract it from this side too, 9840 kilograms times meters per second. All right, so after we subtract that, this is going to equal 0, right? Because that minus itself is 0. And now I have 7070 minus 9840. All right, so that's going to equal a negative 2,770. And my units stay the same, kilograms times meters per second. Great. All right, and now I still have 2019 kilograms times V1. Okay, so now I'm not done yet. Again, I'm trying to isolate V1, so I'm still working PEMDAS in reverse. So I took care of any addition and subtraction. Now I need to see, is there any division or multiplication? So because these are written right next to each other, I know that there is multiplication happening here between this number and the V1. So in order to get rid of multiplication, I need to do the opposite operation. All right, so that means division. So these are being multiplied. So I'm going to divide 2019 kilograms. Now again, the reason I'm dividing 2019 is because I'm trying to isolate V1. So I want to get everything away from V1. I want V1 by itself. So I'm going to divide by 2019 kilograms over here as well. All right. Now, when you see it in the numerator and the denominator, you can cross it out because technically it just equals 1. And I can do that same thing for these units as well because kilograms is up top and kilograms is in the bottom. So those get crossed out. That means at the bottom down here, I'm just going to have V1. Okay, so I isolated V1, which is great. Now I just need to finish solving this math. Okay, so negative 2770 divided by 2019, so 2019, equals negative 1.37. All right. And now here I have kilograms up top and kilograms on the bottom. So again, those get canceled out. But I'm left with meters per second, which is good because I was looking for a velocity. All right. So I'm left with 1.37 meters per second equals V1. All right. So this is our final answer. So after the collision, vehicle 1 is going to be moving at 1.3 meters per second. Now, it is a negative number. That negative number doesn't mean that it's moving slowly or anything. Remember, we say a positive was in the direction of east, negative was in the direction of west. So what this tells us is that after the collision, the first vehicle is going to be moving at 1.37 meters per second west. Okay, so the negative sign is just telling us the direction. All right, so hopefully this was helpful. That is us finishing the evaluate step. So we successfully went through all steps of the ICE method. These problems can be long to do, especially when you're first starting out. But as you continue to practice, you recognize the steps more quickly and you'll be able to go through the problems more quickly. But this is great. What we'll be doing later is we'll be using the change in velocity. So we know that initially vehicle 1 was moving 15 meters per second east. After the collision, it got hit so hard that it is now moving 1.3 meters per second west. Now, what we're going to do in future videos is when we know the change in velocity, we can figure out the impulse, which is another concept that kind of helps us understand how the momentum of vehicle 1 changed. But the cool thing is from the impulse, we can calculate the force on vehicle 1, which then kind of helps us understand like force and mass and acceleration and things like that. So just keep practicing these problems. I'm going to post another video about inelastic collision so that we can practice one of those problems. And then I'll be posting some impulse equations later. All right. Thanks for joining. Have a great day.